All right, welcome to sad news, the final application section of chapter 2. All right, after this, if you hate applications, don't worry. We're going on to some theoretical stuff in chapter 3, which will still have applications, but there won't be any new applications. It'll just be kind of revisiting these stuff we've already done in chapter 2 with the new derivative methods that we're going to talk about in chapter 3. So it gives you kind of a good opportunity to review, as well as not introducing really any new application type material. So this is going to be applications of derivatives, business and economics. You can read. And we're going to start by talking about marginal cost. So we talked about marginal cost in the past. We're going to just refresh your memory a little bit over here. Okay. So if I'm looking at marginal cost, if I have some cost function, right, if C of X is the cost function, then again, remember the marginal cost. Marginal in the context of this class, 9 times out of 10 is going to mean derivative. All right. So derivative of cost, marginal cost, derivative of cost. So the marginal cost C prime of X, derivative of the cost function, represents the additional cost of 1 unit at our current production. So current production level. All right. So that's kind of what we're doing. It's the same for marginal revenue, right? Marginal revenue will be what's the additional revenue, right? You can essentially replace this word, right? You can replace these with R prime of X is going to be marginal revenue. And that's going to be the additional revenue from increasing production by 1 unit at our current level. And again, you could do the same thing, right? For marginal, you could do the same thing, right? For marginal profit. Man, now I want some butter. I'm thinking about margarine now. Marginal, not margarine. Okay, so a little refresher. Let's do some examples and get kicking. Example 1. Interpret. If I told you that C prime of 20 equals 3, this is saying the marginal cost is 3. C prime, derivative of C. Derivative of cost, marginal cost, all right? So the marginal cost is 3. What's that 20? What's on the inside of the marginal cost, right? The inside, that's that production level, right? X is how many units we're producing. So this is saying when we're producing 20 units, the marginal cost is 3. Or another way of thinking about this is if I'm producing 20 units and I want to produce 1 extra, go from 20 to 21, it's going to cost about 3 extra bucks. Okay. So at a production level of 20 units, the next unit costs about $3. That's what marginal cost represents. Gives you an approximation or an exact, depending on your interpretation, of how much that next unit's going to cost. And again, this next unit might cost $3 here, but C prime of 5, if we were at a production level of 5, the marginal cost might be a lot higher. All right. Really depends. Do another example. Example 2. All right. Let C of X be the total cost in dollars. And let's say C of X is going to equal, I'm going to need more room than this. It's a long function. C of X is going to equal 0.0001 x cubed minus 0.06 x squared plus 12x plus 100. All right, so a couple of things to unpack here before we even continue writing the problem down. All right. This is a cost function. A lot of times cost functions are cubic functions, right? So what this kind of looks like, let's do it in a different color. What this cost function looks like is a cubic function. It kind of looks like this. All right, so there is some sort of fixed cost. Remember, fixed cost, that's a cost that doesn't depend on our production level. We have to pay this $100 every day, hour, month, who knows the unit of time. We have to pay this $100 regardless of how many units we make. All right. And then early on, for very low levels of production, we're basically paying $12 per every unit. All right. These are pretty small. So for small x, they're not going to do very much. But then they'll kind of incorporate that shape later on as we get bigger and bigger and bigger. All right. So anyway, let's look at what this problem is asking us to do. Marginal cost, this is the cost in dollars of producing X units. Let's say per week. All right, so the fixed cost is it's going to cost $100 per week just to exist. Welcome to life. Woo. All right. Part A, is the marginal cost. We're asking about the marginal cost, asking about the derivative. Is the marginal cost increasing, decreasing, or constant at x equals 100? So if we're at a production level of 100 units, what's going on with the marginal cost? What's going on with the cost of making one extra unit? All right, and this is a question, so let's add a question mark. How about that? So be very careful here, because we're looking at the marginal cost, right? Marginal cost is the derivative of the cost function. And we want to know when this derivative, when this marginal cost, when this is increasing. So a lot of times we say increasing means derivative. But we want to know when this is increasing, so we want to know when the derivative of this is positive, right? Increasing if the derivative of this is positive. Decreasing if the derivative of this is negative. So it's kind of weird because we're looking at increasing and decreasing, but we're going to talk about the second derivative. And that's because we care about the first derivative increasing or decreasing. All right? So marginal cost increases when its derivative is positive. Let's write that down. Marginal cost increases when its derivative is greater than 0. Well, what's the derivative of the marginal cost? All right, that's when the derivative of the marginal cost is positive. Well, the derivative of C prime, that's C double prime. All right, so watch out for this. Usually second derivative means concavity. And indeed, this does talk about the concavity of the cost function, but we really just care about the marginal cost here. Let's take the derivative here. We'll use the power rule, right? Use the power rule. 3 comes down, subtract an exponent. 2 comes down, subtract an exponent, and so on. So I'm just going to go ahead and write it down. The first derivative of this cost function is going to be 0.0003 x squared minus 0.12x plus 12. And we're looking at when is this marginal, how is this marginal cost changing? So we're actually going to find the derivative again. 0.0006x minus 0.12. And we're curious when x is equal to 100. So let's look at the function value when x is equal to 100. Plug in 100, that'll move the decimal over twice. Minus 0.12. This is negative, right? This is negative 0.06. I can do these weird decimal math in my head, which is negative. So it's the marginal cost is increasing when the derivative of the marginal cost is positive. Here's the derivative of the marginal cost here. The derivative of the marginal cost is negative. So the marginal cost is decreasing at this production level when we're producing 100 units. Who knows what the marginal cost is here? But if we increase production a little bit more, the marginal cost is going to go down. So maybe we have this manufacturing facility and we're under our capabilities. We're not producing as much as our capabilities. So it's going to cost a little bit more to make more units, but the marginal cost, that additional cost of units, is getting cheaper and cheaper as we kind of ramp up to our like optimal production level in terms of cost and our equipment, right? One way to kind of interpret this answer. Again, like usually, again, let's go back to our cost function. Usually cost functions look like this, right? They're steep at the beginning. They're very steep at the beginning and they're very steep at the end. Because if we're producing, like if we have this entire manufacturing system, right? And we're only producing 2 units, those 2 units are going to cost a lot of money relatively. But if we're kind of, got all of our mass production set up and we're kind of operating at high levels as the equipment was designed to do, the cost is going to be cheaper, right? You're still going to have to pay more, but it's going to be relatively lower for each individual unit. And eventually, right, you're going to overtax yourself. You're going to go into overtime. You're maybe overheating the machines or whatever. And eventually that marginal cost is taxing your facilities too much. And that's why the slope of the cost function gets so big over there. So kind of one way to interpret this. Anyway, let's do part B and then we'll be done with this video. Part B is find the minimum marginal cost. So again, be very careful here. We want to minimize the derivative. The minimum occurs at critical points. So critical points of C prime are when its derivative equals 0. Let's copy that down again. That's second derivative. Negative, or it's 0.0006x. Minus 0.12. We want to know when this is equal to 0. So we'll just add 0.12 to both sides, right? And then divide by that coefficient and get our answer. If we divide 0.12 by whatever the heck that is, we're going to get something. Oh. Is what I wanted at all, but it'll work, right? 0.12 divided by 0.0006 is going to be 200. So the marginal cost is actually minimized at a production level of 200 units. This is when the marginal cost is minimized. But remember, the problem asked, find that minimum marginal cost. We have to plug that in, say, okay, this is when it happens. What's the marginal cost at this place? We'll look at the marginal cost. When x is 200, we'll plug that into C prime. And I should have had this ready. We plug in 200 into C prime. We're going to get 0.0003 times 200 squared minus 0.12 times 200 plus 12. That's interesting. Did I plug this in correctly? There's no way I plug this in. There's no way I plug this in correctly, right? I should have looked at this example problem before I started this video. The minimum marginal cost is actually 0. So for this cost function, there's actually a point where it doesn't cost anything to make an extra unit, but it's only for this specific moment. And as soon as this moment passes by, the marginal cost is going to start increasing and it's going to be more expensive to make new units. All right. So let me just double check. I really am plugging this into the right function, right? First derivative. Yeah. All right. It's kind of a funny coincidence for this problem. So that's our minimum marginal cost, is $0 when producing 200 units. So yeah, we should probably produce at least 200 units. Probably more than 200 units, but we'll talk about that in another video. Good luck.